Hey, algebra students. In this lesson, we're going to be talking about measures of central tendency when we're dealing with data. What is a measure of central tendency? First thing we need to do is define it. And while that phrase is pretty technical, it's probably something you've thought about before. Okay, so let's just take a look at the definition. A measure of central tendency is a value, a single value that represents a data set. So if I gave you a set of like all of the heights of the students in algebra class, there'd be a lot of numbers to take in because everyone has their own individual height. You might have some numbers that are the same, some numbers that are different. But what if I wanted to give you one height that represents essentially what the height is of a student who's taking algebra? Uh, if I want to give one number, I would need to choose a good central number, a value that describes the center of the data set. So, like that number is pretty much representative of what you would expect the height of a student taking algebra to be. Even though we'd understand that every height is different, it would be a good representation of the height. That number, that single number, is a measure of central tendency. Now, you may not have heard the phrase measure of central tendency before. Honestly, you probably have. But if you've probably heard the three measures before: the mean, the median, and the mode. Those are probably terms you're familiar with. The mean or average is one we have to calculate. It's the one that's the most work intensive to find. You add all of the values in a data set together, like all the heights of the students in algebra, and you divide by the total number of values. I don't know if you've ever thought of this before, but a mean is actually a unit rate. It's a ratio, right? We're taking the ratio of the sum of the data values to the total number of values. So really, what we're saying is, if we have like the average, let's say the average height of students in our algebra class was 5'6" or something like that. So we would say there's 5 feet 6 inches per person in algebra. Now, not every person is exactly 5 feet 6 inches, but if we added together 5 feet 6 inches per person for each person in class, we'd have the total height of all of the people in our algebra class. So a mean is actually just a way of using a unit rate. And that connects it back to something we learned about earlier. You do need to know that to calculate the mean, you have to add all the values in a data set together, then divide by the total number of values. And you've probably done that so many times, you know exactly what that is. The median is the middle number of a set of numbers when we arrange those numbers in order from least to greatest, or technically from greatest to least, but we don't really do it that way. So you have to know that to find the median, the first thing you need to do is arrange the numbers in order. If you have an even number of values, you need to find the median by finding the middle two values and then finding the mean of the middle two. So you just add the two up and divide by two. Now, sometimes when finding a median, yes, you do have to calculate a mean. Other times you just count up the number of numbers, find which number is the middle number. In an odd numbered set, as long as you have an odd number of data points, the middle number is just going to be a single number. And then lastly, the mode. There are times where it is valuable to use the mode as a measure of central tendency, but this is the one that's it's used the least often. And what it is, it's the value or values that occur most frequently. So we count up how many times we find each value in our data set. And the one that appears the most often is the mode. Sometimes we'll have two or three or four or multiple modes because we'll have numbers that appear the same number of times as other numbers. That's how you find the mean, median, and mode. Now, all right, let's give this some practice. Letter A, find the mean, median, and mode of the values in the data set. Well, mean is the one that's the most straightforward. I'm going to have to calculate this by adding together all of the numbers. So I've got a calculator here, and I'm going to add together all of the numbers in this data set. 46 plus 33 plus 25 plus 21 plus 38 plus 25 plus 30 plus 15 plus 28. All right, like I said, this is the most work-intensive thing to calculate, and you want to double-check your work to make sure you didn't miss a number because it's really easy to make a mistake as you're adding this many numbers together. Now I'm going to divide by the total number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to divide 261 by 9. 29 is the value I get. So letter A, I add up all the numbers and divide by 9. 29 is the mean. The median is the second one we're going to do. Well, I notice there's 9 numbers in this data set, but I can't find the median until I list these numbers in order, and I'm going to do from least to greatest. So the reason it's important to cross off the numbers you've already listed, it took me a long time, and I actually had to go through and actually cross off numbers to figure out that 25 was listed twice because I just didn't just see that initially. All right, now I've got my numbers listed from least to greatest. Now, because I have 9 total numbers, that means that the middle number is going to be, let's see, the fifth one, because there's 4 numbers above it and 4 numbers below it. So I'm just going to go ahead and put a box around that middle number. That is my median. So 28 is the median for this set of data. 28 median. And then the mode is the number that's listed most often. Every one of these numbers is listed just once, except for 25, which is listed twice. So 25 is the mode. All right, letter B. Do trucks or convertibles have a greater range of sales over the 8-week period? Well, let's see, a greater range. Range is the highest number minus the lowest number. For trucks, the highest number, let's see, 415 is pretty high. Oh, 560, that blows that out of the water. So 560 in thousand, so it's 560,000 technically, minus the smallest, looks like 125 is going to be the smallest, $125,000. Let's see, 560 minus 125, that's going to be 535, 435, $435,000 in range. For convertibles, let's see, the lowest number, looks like people are consistently buying convertibles here. 600 is the lowest, 600,000. And the highest appears to be 810. So it's going to be 810 minus 600 is 210,000. So trucks have the greater range because it's the greater difference between the highest and the lowest. All range is the highest number minus the lowest number. That is not a measure of central tendency, but it is a useful measure to consider when thinking about data sets. All right, letter C. The following data set shows the ages of 20 students graduating from college. The first thing we're asked to do is find any outliers in the data set. All right, so what I'm going to do is I'm just going to list these in order again. So do I have any outliers in this data set? Well, 59 and 64 are way different from where all the central measures. So 21, 22, 23, 24, 25, 26, those are all really close together. They're really centered around the median or the average. 59 and 64 are outliers. How do outliers affect the measure of central tendency? Well, they're going to pull the measure of central tendency up for any measure, except for the mode. Let's think about this for a second. If I were to add all of these numbers together, outliers really badly affect the mean. And we're going to just see how much 24.45 is my mean. What about my median? Well, the median, I've lined them up in order. So I need to find my 2 middle numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's this 22 and this 22. My median is the same as the mode because 22 appears so often in this list, it's right in the middle. So what that means, my outliers affected my mean a lot more than they affected the median. And that's very true for all sets of data. Outliers will affect the mean more substantially than they affect the median. Just for the record, the mean without the outliers, if I remove the outliers, is 21.61. So those 2 outliers are pulling my mean up by about 3 years, which is pretty significant. So the median is sometimes really good to use as a measure of center if you have outliers. And then letter E, the following data show the annual mean price of regular gasoline in 10 cities across the U.S. in 2005. 226, 232. So yeah, these numbers. What is the median price of a gallon of regular gasoline among these cities in 2005 in dollars? Um, so to find that median, I need to list these all in order. All right, so that means that I have two middle numbers, 230 and 232, because there's 10 total data points. The median is going to be the mean of those two middles. So halfway between 230 and 232 is $2.31. So I'm just going to write $2.31 as my median. If budgeting money for gasoline, would you use this measure of central tendency? Well, honestly, here's the thing. This is 10 cities across the United States. Um, if I know what city I'm living in, it's going to probably this isn't going to be useful because unless I'm driving across all 10 of these cities, and because I'm driving through cities and I'm going to need to stop maybe in any one of them, it'd be good for me to use this median. But chances are I live in one of these cities, and instead of using this to budget gas, what I should use is the cost of gas at various times during the year in the same city. So this would not be a useful measure of center for me, as somebody who's budgeting money for gasoline. I would need to do the same city where I'm actually buying gasoline over time. All right, and that is how you work these problems. You are ready to do numbers 1 through 30 for next time.